In addition to powerful geometry creation and manipulation tools, SolidWorks software provides analysis tools to help you create better designs. TolAnalyst is one such tool. TolAnalyst is a tolerance analysis application that determines the effects that dimensions and tolerances have on parts and assemblies. TolAnalyst tools lets you perform worst-case tolerance stack-up analysis on parts and assemblies, traditionally a tedious task for designers. TolAnalyst works with parts that have been set up with DimExpert, another excellent tool seen elsewhere in this video tour series. Here we have an assembly where we want to ensure that as part of our design requirements, we have a dimension of 100 millimeters plus or minus 0.5 millimeters between the face on the bottom plate and the face of the slot on the holder part. To begin the analysis, we select on the DimExpert Manager tab of the Feature Manager and select TolAnalyst Study. This process requires 4 simple steps. First, we create the measurement between the face on the bottom plate and the face of the slot on the holder part and place the dimension. Using the arrow keys in the TolAnalyst wizard to move to the next step, assembly sequence, we have to indicate which parts are involved in the assembly between the bottom plate and the holder part, selecting them in order. The next step is to define how these parts are assembled together. The riser part will be assembled by placing the faces together and then lining up the holes. We set the constraints to match this sequence, primary being the faces, secondary being one of the holes, and tertiary being the other hole. Next, we establish how the holder is assembled. As you can see, TolAnalyst identifies all possible assembly constraints. In this case, the most appropriate primary constraint is the notch in the holder and the bottom of the riser. In this case, this is sufficient to continue with the analysis. Notice that when the TolAnalyst wizard detects that enough information has been provided, the message turns green. The final step is the analysis summary. Here we see that TolAnalyst has calculated the nominal, minimum, and maximum values, based on the tolerances specified in the individual parts. By selecting the values in the analysis summary box, the location and direction of the minimum and maximum are shown in the graphics area. Remembering our goal was to have plus or minus half a millimeter between the two faces, we see we are not meeting that requirement. So what we need to look at are the various contributor dimensions and tolerances. In the min-max contributors window, TolAnalyst has determined which dimensions and which parts have the most influence on the results. You can see we have some heavy contributors to the stack-up. If we click on any one of the contributors, we see the dimension in the graphics area. We can see that the dimension is 123 millimeters plus or minus 0.5 millimeters. By selecting the dimension, we can change the 0.5 millimeters to 0.1 millimeters. By selecting the Recalculate button, the analysis summary will update and you can see the change we made affected the analysis summary. We can now see that the two new major contributors are in the same part. So let's open that part and examine the dimensioning scheme. Here you can see that this dimension controls the top of the part to the small shoulder, and this dimension controls the top of the part to the top face of the slot. What we are really doing with this dimension scheme is building in a double tolerance from the top face of the slot to the shoulder. To rectify this, we can delete the dimension and simply change the dimension scheme. To do this, we select the location dimension in the DimExpert toolbar. We will add a dimension from the top of the slot to the top of the shoulder. Returning to our TolAnalyst study, we can see what changes have occurred. You can see in the analysis summary that we have reduced the tolerance, but we are still short of our goal. In the contributors window, we can see that the new dimension contributes 62